here. Hey, for fun, do you guys want to finish this one? I mean, I just made this up real quick, but if I wanted to find the vertex, she said we find the x value with our little formula. Let's just try that real quick. That'd be a -8 over 2 times a. That's pretty nice, actually. That's a -8 over 8, which is -1. Sometimes it doesn't come out all that nice. Sometimes it's a 2/3 or a 3/5 or some decimal, but anyway, that's nice. But if you want the y value now, you plug -1 in for x. Right, it's not too hard. I can practically do it in my head. -1 squared is a +1 times 4 is 4. That would be a -8 when you plug in a -1 and a -7. So I guess this y value is -11. Wow, that's a lot of ones going on there. I like that. So my vertex is -1, 11. If I wanted to sketch a graph, I'm sorry, -1, -11. -1, -11 is the vertex. You know, I label my x-axis, I label my y-axis, and I have a parabola sitting here. Does it open up or does it open down? It opens up because of the +4. By the way, that 4 is going to make it pretty darn skinny, I suppose. Hey, what's the y-intercept? Oh, the y-intercept is right there, -7. When you plug in a 0, you get -7. That's real easy. That helps me kind of graph it if I know that y-intercept. Yeah, that's beautiful. So I like to kind of write all this down and list it, but I guess I still could. But the vertex is, we've got the vertex. We talked about the y-intercept. I mean, again, if I'm filling this in here, I'm sorry. -1, -11. I always ask for the x-intercepts. Maybe we'll get there. The y-intercept is -7, 0, -7. Thank you. Hey, by the way, what's the range? That's always easy. After you kind of get this rough graph going here, you can easily see the range. What is that? Y is greater than or equal to -11. Yeah. That's the range. It's all the y values above, you know, wherever that vertex is. It's usually that vertex and up. Or, if it's an upside down parabola, it's the vertex and down, I guess. Right. Yeah, good. I mean, we've been doing this question kind of every day since we opened chapter 3. Here's a parabola, find all this information, you know. And then I always save the little hardest bit for last. These x-intercepts are always a little tougher. In order to find the x-intercepts, I have to set y equal to 0. You know that. And now I'm solving a quadratic equation. And I've tried to outline that for you pretty well. You can either factor it or use the quadratic formula. Sometimes you can move stuff over and take the square root of both sides, but not on this one. It's not really set up like that. So you really can either factor it or do the quadratic formula. And rather than waste time trying to factor it, maybe you should just do the dang quadratic formula. I mean, I kind of doubt it factors. Yeah, it doesn't factor real quick. So the quadratic formula on your mark is set. No, I'll race you. It's not really a race, but once you get good at it, then you can dispel the boredom a little with a race.
With the quadratic formula, is a -b?
Yes.
You change the sign.
Well, it's -b, and b is 8. So it's -b is how it starts. Kind of like the same with this vertex formula. Yeah, it's -8 plus or minus the square root of that b squared. And I just go ahead and do b squared. -4 times the a times the c. All over 2 times a, which I'll just call that 8 if you don't mind, 2 times the a. So there it is. And then it's a matter of cleaning up what's inside that square root. That's all. And try not to do some bad moves. You don't want to cancel that. That's bad. You got to work in this square root here. And what I've tried to tell you before is I see these 2 negative signs. That tells me I'm going to add this. And what it is it's a 16 times 7. Oh my gosh, that's 102, I think. And I'm going to add it to this 64. So I think I get the square root of 166. Bless you. I just did that in my head.
16 times 7 is 112.
Oh, thank you. I screwed up. Made a mistake. On video. That's okay. Everybody makes mistakes. That's part of the lesson. 16 times 7 is 112, he said. I said 102, so I was wrong. 112 times the 6, added to the 64 is 176? 176. You know, I'm happy with this answer, except it might not be totally simplified. Listen, I don't mind you. When you have a square root of 12, well, I've done this a million times, you probably ought to simplify the square root of 12. What is it? It's 2 square roots of 3, because it's a 4 times 3. You pull out the 2. And when you have the square root of 176, I mean, whatever. You can try to simplify it, but I don't want you spending hours trying to simplify it. Is it 4 times something? Is 176 4 times anything? What is it?
4 times 11.
44.
Oh, it's 4 times 44? Yeah. It's 4 times 44. Well, and hang on, that's a 4 times 11. So you know what it really is it's a 16 times 11. Is that okay with you? But first you got to realize, okay, it's 16 times 11. Am I right about that? You can double check that. Okay, so if it's 16 times 11, then can you do the square root? Now you're trying to do the square root of the 16. So what do? You pull out a 4. That 4 that comes out is right in front of the square root. It's multiplied right in front of the square root. And then what's left inside? An 11. Okay, well then we did simplify this square root. You can do it, but you know it takes a little extra effort that I don't know if I'm that interested in that. By the way, if you are going to simplify it and pull out that 4, then you can do one more little simplification down here. He said cancel a 2, and it's okay to cancel a 2 as long as you cancel it in all 3 places. Cancel it there, cancel it there, cancel it there. But not a 2. How about a 4? Yeah, let's cancel a 4. If I cancel a 4 there, there, and there, I'm left with -2 plus or minus square root of 11 all over 2. I just canceled a 4 out of those 3 spots there. You know, so from here to here is you know, something you ought to be able to do. But I know it's also a place students struggle. If I say you can stop here, you're going to love me forever. And I'm sort of saying that, but you know, it's also good if you're doing your My Math Lab homework, or you might not be able to stop here. If you're searching for their multiple choice answer, or if you're doing a multiple choice test, you might have to finish it all the way to the bottom. If this was a word problem, what have I preached? Do you know what I've preached in a word problem?
Decimal.
Decimalize this. Yeah, go for it. Decimalize this. I want to know the time it hits the ground, or I want to know something about the word problem. Right. That's good, you guys. By the way, whatever those 2 answers are, those are my x-intercepts. I can write them over here. I can write -2 plus or minus the square root of 11 all over 2, comma, 0. Those are my 2 x-intercepts. You know, I don't really know what they are, but there they are. Yes, ma'am?
Why do we add the 0?
Well, you know, what I'm listing is an x-intercept, which is a point. And at this point, it has an x value of something, and it has a y value of 0.
Okay.
So I'm listing a point. Like when I listed that y-intercept, the x is 0, the y is -7. I'm listing it as a point.
Okay.
Okay. Any other questions? You were going to ask me about one of these farmer problems?
Any of them, yeah. Take a card, any card.
Okay. Well, so on your practice piece of paper, did you ever get one?
No.
Even my last email? I sent one last email, but you can have that.
Do you have an extra?
Maybe. Anybody else need one? Nice practice piece of paper. Okay, I'm running low now. So there is these word problems. These are good. They're a little tougher. Well, we worked on one. And so I'll do this number 10. So on this practice piece of paper on page 3, there's this number 10. And it says that the farmer has 360 feet of fence. So I'm going to write that down. He's got 360 feet of fence. And he's going to build this goat pen for his goats. And it's kind of, you know, the paragraph says that one of the sides is up against the barn, so he doesn't need a fence over there when it's up against the barn. But he does put a cross fence in there across the middle. But what's really nice is I give you a picture of it, which is nice. And so the picture looks like this. He's going to build this fence. There's a cross fence there. But right here, there's a barn. And so if there's a barn here, you don't need a fence. And then what I did was I labeled this width X. And by the way, I did that for you on my picture. But then it's your job. If you label that X, what's this?
X.
What's this? X. And I think the first question you should ask yourself is after you label those three things X's, you should ask yourself, how much fence is left? I mean, he has this total, and then he just built this X, and this X. So he just built 3 X's. And so from this total, you should subtract 3 X's, and now how much fence is left? Say it. Go ahead and say it. 360 minus 3X. 360 minus 3X. And then in some problems, you got to divide that in 2 because you got to put that on that length and on that length. But on this problem, we don't need a fence over here. There's a barn here. So what do I do with all my fence that's left? My 360 minus 3X. Where is it going to go? It's all going to go right here on this length. Are you guys okay? It's pretty easy. You got your total amount of fence. You got these widths. You label these widths X, and then you subtract them from the total, and that's how much fence is left. And then you got to know what to do with that. It goes on that length. If there was another length, though, that's the little catch. If there was another length, you would divide it by 2 and label your length probably 180 minus, if you divided this by 2, it'd be 180 minus 1.5x. Anyway, we didn't need that for this problem. We just put all the fence there. Listen, the way the question is asked, part A says, and I'm not going to write this, but it's right there, you got it. It says, find an expression for the length of the side of the pen that is opposite the barn. So that I just talked you through all that, but I mean, the question itself is guiding you through to the answer. So this question is well designed. If you do part A and get part B and you'll just follow right into the answer. But part A says find an expression for the length of the side. So we did that. So the answer to part A is that length. I could call it L, whatever. Then it says, part B says, write a function for the area of the pen. So now I want to write some kind of function for the area of the pen. Well, don't worry about all the little cross fences. Just look at the big rectangle. I think it's got a width, and I think it's got a length. So the area is the width times the length. I mean, it's that easy, isn't it? I know when you read this, you know, I don't know. Maybe you get confused reading it, but it's guiding you to the answer. Like I said, the first question A wanted a length, wanted something for the length. So we came up with that. That led me to this because I need width times length for my area. And then they want the dimensions that maximize the area. You know, it's probably smart to work on this. This is the area function, but it's kind of smart to work on it a little bit. Let's work on it a little bit. Let's distribute the x. 360x minus 3x squared. And if you don't mind, I also like to change the order of that because I'm used to things being in order, which means negative 3x squared plus 360x. Are you guys okay with that?
Yes.
I just swap these orders. But that negative sign is still on that number, and that positive sign is still on that number, right? So I just swap the order of those. But now I think they want me to find the x. They want the dimensions, but that means let's find the x that maximizes this goat pen. And when they use that word maximum, what do I think of? Vertex, right? So I think I'll try to find the vertex. Okay. Negative b. There's my negative b over 2a. This is awesome. That's a 360 over 6. The signs cancel. And so it's a 60 feet. They asked for dimensions is what they asked for, and what we just found was the width. I mean, we found x, and x is, go back to your picture if you want, x is the width. So that's sort of just half the dimensions. Now I need, dimensions means I need the width and I need the length. What would you do to get length? I just go back to this, right? This is length. So when I said let's find the vertex, I really didn't mean let's find the entire vertex, did I? Because you saw what I did? I found the x value of the vertex and I stopped. I didn't even bother with the y value of the vertex. The y value of the vertex is not the length that I'm looking for. The y value of the vertex happens to be, what is this y value right here? It's the area, right? And I might need that, but what I really wanted was just these dimensions. So I wanted the width here. This x value really is I feel like is all I need. I feel like I need the x value of the vertex. And then to get the length, I can plug it back into this. 360 minus 3 times x. And so the length is 180, I think. Yeah. So now, what are the dimensions? 60 feet by 180 feet. Good little problems. I mean, but if you listen and follow my logic here, you can do these. They're really not that hard. The more I do them, the easier I keep thinking, wow, these are easy. I used to think they were tough. I've just done 20,000 of them in my life. Now they're pretty easy. I'm reading the question, part A, part B, part C was what are the dimensions? So this is the answer to part C is the dimensions. And then part D says, what is the maximum area? You know, like we said a few minutes ago, the maximum area would be the y value of the vertex. If you took 60 and plugged it in there, you could get area. But I didn't really teach you that last class. Last time I said, look, if you already got the dimensions, then don't you got the area? Which, by the way, that is your 60 and 180. If you go back here, that's your 60 and your 180. But here it is, right? So the area is, so this is part D. The area is the 60 times 180. Actually multiplied 1,080 square feet.
No, 10,800.
Oh, 10,800. Yeah. Okay, 10,800. Okay, thank you. Yeah, thank you. That's all right. 10,800. That makes more sense. 60 times 180, 10,800 square feet.
Now you're number 11.
Well, I could. Number 11 says, repeat number 10, but now you have 2 lengths. So we could do that. Let's pause here a second. Are you guys okay with this number 10? Any questions? So to do number 11, if you don't mind, I'm gonna just do it right on top of this one. What number 11 says is, okay, now there is no barn there, and you actually have 2 lengths. Okay, so we speculated about this a second ago, but now let's actually do it. So now I actually have a length here. I'm building a pen, and there's no barn there. So what do? We start by saying, oh, that's x, that's x, that's x, and then we say, I say this, how much fence is left? And the answer was 360 minus 3x. But now I have to put, I don't put it all on that length. I have to divide it in 2. Not divide it in 2. So I have to take that 360 minus 3x and divide by 2. And that goes on this length, and it goes on this length.
180.
Well, and what is that? Sure, go ahead and divide it by 2. It'll make it a little easier. Sure, that's 180 minus, and you could call it 3/2, or you can call it 1.5x, right? That's awesome. That's your new length. Do you understand that? It's just the old length divided by 2. The old length was we only had 1 length because of the barn. Now, problem 11, we don't have a barn, we have 2 lengths, so we divide this by 2. It's cool. And then it's the same. So that's it. The beginning of the problem is different right there, because you take that and divide by 2. The rest of the problem is the same. I mean, it's different numbers now. This area formula is now x times 180 minus 1.5x. When I distribute it, it's 180x minus 1.5x squared. When I write it in a different order, it's negative 1.5x squared plus 180x. Are you guys okay?
So will you have the same dimensions?
I don't know. No, we'll finish it. But I just paused for a second. Are you guys okay? All right, let's keep finishing here. So now I want to know when this area is a maximum. So I find the vertex. It's going to be, this time it's negative 180 over 2 times a. Let's see. That is interesting. That's 180 over 3. It's still 60. That is pretty interesting. It's still a 60. The width is still 60. Remember now, this length ain't going to be the same, right? Bless you. We used to only have 1 big long length. Now we got 2 lengths, so we're going to have a shorter length. But the 60 is still the same 60. That's interesting.
Will be negative?
What negative?
The 60.
No, none of these distances should be negative. So every once in a while, think about the reality of the problem. This is a distance. We don't call a distance negative. It's 60. But it shouldn't have been 60. This was, see this negative and this negative?
It cancels.
It cancels, so it's positive. Right. Well, anyway, now I guess instead of this length to get the dimensions, I needed my new length formula, which was the 180 minus the 1.5x. So this time I'll get a different length here. I think that's 180 minus 90. I think that's 90. Well, that makes total sense. My length is cut in half from what it was a second ago. Instead of that 180, now it's cut in half. It's 90.
So 90 times 100 is 16.
So my dimensions now are 60 by 90. And my area is now 60 times 90. I got a different area. It's exactly half. It's 5,400 square feet. Everything's exactly half. That's interesting. I guess it makes sense. I mean, when I had that barn, I was able to take all that fence and make a big old long length. But without the barn there, I got to cut that down. I got to cut that in half. I got to make a shorter length and then another shorter length to make, I got to go all the way around the pen.
What, the 360 minus 3x over 2 kind of tells you basically you're just cutting it in half.
Well, I know. I'm cutting the length in half. What I wasn't sure is how that would affect the answer, but cutting the length in half ends up cutting the area in half. Right. makes sense. It did not change the width, it turns out. That was kind of interesting. I wasn't sure, but it didn't change the width at all, but it did cut that length in half, yeah, which resulted in cutting the area in half, right? Yes, sir?
On number 10 for C, where do you get 60?
So where did I get my original 60? By finding the x value of the vertex. So, see what I did was part B said, can you make an area formula? So I made an area formula with width and length. So there's my area formula, there's my area formula. And then they said, maximize the area. And that means find out when it's a maximum, which is find the x value of the vertex. So this x value of the vertex is my negative b over 2a that I've been practicing, but here it is in the context of a word problem. That's what led me to that 60. Yeah, that x value of the vertex. Once you build your area formula, and here I am doing it again. Here's my negative b over 2a with my new problem here. Sorry, you can't read that too well. That's a 2 times negative 1.5 here. Any other good questions you want to ask me? Yes, ma'am?
You do number 13.
No. Well, I mean, I can. But I'm sort of running out of time. And that's a tougher problem. Did you guys read 13? It says redo 12. 12 is a good problem. 12 has 2 links. But then 13 is something nobody's ever, 13 is weird. What's 13 doing? Did you read it? In 12, you got one of these pens. You do have 2 links. You do have a couple of cross fences. So good luck working on 12. But her question was 13, and the reason she's asking 13 is because it's a tough one, man. What does it say? I put gates in here. I put 10-foot gates in each of the widths x.
Oh, okay.
Yeah, so I put a 10-foot gate right here. So I don't need a fence. I need to put there's a 10-foot gap. There's no fence right there.
On each?
I think I did it on each one. I put a gate, a 10-foot gate, a 10-foot gate, a 10-foot gate. That's so I could bring my tractor in there. You know how it is. You know how farmers are. Wow, man. So look at that. I mean, that's a twist. Maybe I put a little 2-foot gate right here for me to walk in. You know? Maybe I put an extra little fence right here just for fun, just to mess with you. Now I'm getting weird. As if I wasn't weird before. Now I'm getting weird. No, I'm kidding about the 2-foot gate. The 10-foot gates are hard enough. What would you label this now? I mean, you could label it X, but maybe you should call it
X minus 10?
good. You could call all this X minus 10. How many of those do you have?
4.
You have 4 of those.
So 4x.
So what, X
40.
4? Or? So 426 minus 4.
Yeah, 40.
How much total fence is this one?
426.
426 total feet of fence. You got 2 of these L's, don't you? I've been trying to get you to do these L's in your head, kind of. I mean, but on this one, it might be better to write all this down. Watch this. If you add up the 2 L's and then the 4 X minus 10s, are you guys following me? The 2 L's and the 4 X minus 10s, what do you get? When you that's your total fence. Yeah, thank you. I think that's your total fence. Now, could you solve for L?
Yes.
I think you could. It's not really as hard as you think. When you distribute this 4, you just got this extra damn 40 hanging around that you need to deal with. If you distribute the 4. But then you would subtract the 4x and you would divide by 2. Why would you divide by 2? Because you got 2 links, right? Okay, listen, so I got you started on number 13. I'm not going to finish. Okay? She asked about 13 and I got her started. But I'm not going to finish today. I might finish again if you ask me again. Any other questions? Yes, ma'am.
On number 4,
Yes.
part D,
Yes.
where does the 180 feet go?
Good question. Let's talk about this guy instead of this. So she's asking about number 4 on the practice. Number 4 on the practice is one of these classic questions. This is a good question where you throw something up in the air. It's a different kind of word problem. And I know she asked me about D, but let me build up to it. What I give you is a height equation. It's negative 16t squared. I mean, you're focused. You can read the whole word problem, but the truth is, you need this equation is what you need to read. 72t plus 104. If I do read the word problem, what it told me was that this person was 104 feet up above the ground, and he threw this thing up in the air. What was he throwing this time?
Baby alligator.
A baby alligator. That's not nice. That is not nice. Must have been a damn Seminole, probably did that. Anyway. Excuse me. He was up here on the bridge. He caught this baby alligator. He threw it up in the air, trying to throw it back. He was actually trying to be nice. Threw it back. And what's the first question? When does it reach maximum height? What's the next question? What is the maximum height? I would say both those questions are about the vertex. Would you agree?
Yes.
And that's not that difficult. I might just not help you with that. Part A and Part B are both good vertex questions. One is the x value, one is the y value, right? By the way, when you say x value now, in a problem like this, when you say x value, you mean t value. I mean, instead of x, we're using t in this problem, and t is time. And when I say y value, I'm talking about this y over here. This y is the height. Makes sense. So we could do A and B, but she asked me about D. What about C? C says, when does it hit the water? By the way, I guess the floor or the ground. Sometimes this is called the ground, but in this case it's called the water. Okay, he's falling back down to the water. But what height is the water? 0. So when it says, when does he hit the water, I should plug in a 0 for the height. Do you guys agree? Okay, now that helps. Listen, that helps you answer her question, because your question was for part D. What did it say? There's a bird flying around up here? There's a hawk flying at 180 feet. There's a hawk flying at 180 feet. And the question is, when does it hit the hawk? So when the question says, when does it hit the ground, you set this equal to 0. If the question is, when does it hit the hawk, you set it equal to 180. So you set 180 equal to this. I'm trying to be nice and logical here, you know, I mean, it's logical. It's not supposed to be mysterious. You got to just pay attention to that. You were given a height, and you were asked, when does it hit that height? So you're asked for the time when it hits that height. But now, I mean, here you are. I mean, you got to know where to plug it in. That's kind of what her question was. Where do you plug it in? And so I helped her. You plug it in over here. But now do you know what to do? How do you solve this kind of quadratic equation? The first step is you kind of got to make it a 0. I mean, even though you set it equal to 180, the first step is you want to get rid of that 180. So what do? You subtract it. You subtract it away from here, and it's a 0. And you subtract the 180 over here. If you subtract that 180, I think you get a negative 76. So this is your new quadratic equation you got to solve for part D. For part C, what do you got to solve? For part C, you're solving this. You guys okay? When does it hit the ground? For part D, you're solving this. When does it equal 180? And you're solving this. Both of them were probably nasty quadratic formulas. they are word problems, so when you get some nasty numbers in there, you pick up your calculator, you decimalize, you carefully work your way through. You can find these times. You can find these times.
So these will be decimals?
Yeah, we decimalize these, and they'll be nice little decimals. Yes, ma'am.
You're gonna have two different times that the bird can get hit.
I think you'll have two answers here. Unless there is one little funny issue. What if max height? Well, see, if this max height was 200, and I ask you when it hits 180, then I think there's probably two times. Do you agree? Okay. What if max height was 150, and I'm asking you to hit 180? When are you going to hit 180? You're not. So then you'd have no answers. How would that play out in the math? How would no answers show up in your math? You get imaginary answers. You get a negative number in your square root. You would get imaginary answers. That would indicate that there's no answers. Right. And you know what could happen? What if the max height was 180? And then I asked you when the bird was at 180. Then there's not two answers, then there's one answer, I guess. Which is right at the vertex. Huh. Be cool if the bird was hanging around right at the vertex. But that'd make it easier. Well, we probably should stop and do a little quiz. I answered some of your questions. I'll tell you what I didn't get to do is I wanted to push into 3.4, and I didn't get to do that. So I think I'll do that Thursday. And now I'm happy I pushed the test back because I don't. So this is good. We pushed the test back a day, and this Thursday I'll answer more questions. I'll get into 3.4 a little bit.
Is there 3.5?
I don't think so. Or if there is, I don't go there. So now we'll just stop. I'm going to hit stop, and we can spread out a little bit.